Good morning. It is such a pleasure and an honor to be here at an event that will be matched. The beauty of the surroundings will be outshone, I'm sure, by the conversation that we're going to have today. It's a room full of very interesting and knowledgeable people, and I cannot imagine a better group to have this conversation with about data. So, actually, when Herr Huntmacher showed the safe with the lock and talked about how important data is as an asset, my heart sunk, and I thought, oh no, this is going to be a day about locking away the safe. So I was so happy when you swung open that door to show the gold inside the safe. In fact, I want to talk about the door swinging open all the way, because I think that's what's happening. And it's not happening in every business, nor should it, but it is, I think, the general trend. It's where we are going. This door is opening greatly. And so we're moving from a time in which we as a culture understood facts and understood them well, and we thought we understood data and information, to a time in which we are moving to, I think, very rapidly moving to a very different idea of what these things are. And if it's all right with you, I want to spend just a couple of minutes remembering the history that is the context for this change. It's one in which we have taken facts as being the bedrock of reality. But that idea itself is a very new idea. That idea has a history. It's not obvious, it's not obviously true. And in fact, I think it's being challenged by the new regime of data, the new idea of big data, data sense of mind. So this will be very fast, don't worry. But so 2,500 years ago, Aristotle and his followers, which are basically all of us, one way or another, even if we don't want to be, we are, facts were not important to Aristotle. The concept of fact, of course, did not exist, and facts themselves, that is the focus on the particular, a fact about a particular thing, was beneath the dignity of human beings. Because animals also can perceive facts. An animal can perceive that there's a red spot, an orange spot on this bird's chest, or that this bird is red. Those are facts, but it's what we share with animals. Our ability to perceive that we share with animals, to perceive the particular. The task of the human, according to Aristotle, and then for 2,500 years of Western history, has been to go above what we sense, to what we, as humans, in this view, are uniquely qualified to do, which is to see the universal in the particular, to go above the particular and to understand that each of these looks different to the cat. We're able, as humans, to see the concept, the universal of bird, and not only that, to see this within the entire ordered structure of the universe. It is our task as humans, it has been our task as humans to understand that ordered structure. And so facts, being that which we have in common with animals, not very interesting. The real task of humans was to see above the facts, to see above the particular. Facts began to take on some more dignity, let's say, in our culture, when Francis Bacon, in around 1600, who's of course famous as one of the founders of modern science, paid some attention to facts, but in order to ground theories, and theories themselves are universal. But still, facts, we started to pay more attention to the particular. But facts only really took on their current central role in how we think about knowledge, how we think about how we see the world, in the 19th century, where facts arose this role arose not primarily from science initially, but from the social sphere, where it began perhaps to dawn on a culture that the poor were not poor because they deserved to be poor, but maybe for some other reason. And so facts were gathered as a way of supporting social policy, and social policy that went against the interests of the wealthy. You could argue against those interests by saying, well, no, here are some facts that show that, in fact, 8-year-olds working in factories are not healthy, they are not happy, they are not having a good time. This is not a good thing. Facts rose as a result of an interest in social policy and as a way of countering entrenched interests. In our modern world, ever since then, we view facts as, in fact, a picture of the world. We've considered them to be, since the 19th century, they're rare. They're relatively rare. They're assets. They're gem-like. They're expensive to gather. They take a lot of work. But you put them together, and you have the picture of reality. And slowly, bit by bit, we fill in these pieces as we understand our world. That is the 19th century and modern understanding of facts. And this is a very quick example. Charles Darwin spent 7 years, 1847 exploring one particular question, which is one fact, one question of fact. Are barnacles crustaceans or are they mollusks? Now that's a fact for you. He spent 7 years establishing that fact. 7 years dissecting barnacles from around the world, coming to dinner every night smelling like dead shellfish. This was worth it to him and to us. He wrote a 2-volume work. If you liked Origin of Species, you will not like The Origin of Barnacles, his barnacle book. It's intensely factual and detailed. 7 years to establish that fact. That's what facts were like. 7 years, one fact. But done, finished, hard, real. Even in the age of data, let's say at the dawn of the information age, which I, of course, would also mark in 1948, Claude Shannon. In the 1950s, we start getting computers, and even though what we thought at the time was we were being inundated with data, there was too much data, in fact, what was actually going on, as many in this room know, is we were, in fact, so overwhelmed with data that the task of IT was to reduce the amount of data. The information age was about the reduction of data, the reduction of information to what fit into the categories that somebody else deemed useful. And we got very good at this. It's a good thing to do. But we should recognize the information age was about reducing information to what fit into the columns that we chose in our databases. But now we're in the age of the internet, where abundance is the norm. An infrastructure that scales beyond anything we have ever imagined. It scales beyond, we don't know how big it scales, we just know that it's very, 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 very big. And this has changed fundamentally our idea of information and of data. 3 quick ways that it's changed. Data, the first is, well, okay, it scales. Data now scales beyond anything that we'd ever thought. Second of all, when data, one of the possible origins of data and information is Herman Hollerith, who in 1890 had built a tabulation machine for counting the results of the 1890 census in the United States. This was a card counter. He was punching holes in cards, a very familiar model. Data, in this sense, which continued into the information age, is in fact well symbolized by this card, where the data are the holes, but of course, the data that are not holes, where there are no holes, is also data, but most important is the space between the holes. If you didn't have the spaces, these card systems simply would not work. You need to separate your data into neatly punched holes. Data was about this type of separation and isolation. They needed that space between them, crucial to data. So along comes Tim Berners-Lee, who, in addition to giving us the gift of the web, and it's important to always, I think, keep in mind, it is a gift that someone gave us by not copyrighting it and not patenting it. And had he done either of those things, we would not have the enormous benefit, the world-changing benefit of the web. So he gave us this gift, and then he had an idea. He actually looked out at it and said, you know, it's not exactly, I'm a little disappointed, which is hard to imagine if you're Tim Berners-Lee. You're a little disappointed in what you've done, but nevertheless, in my construction of this, he looks out over the web and he says, you know, it's got all this data, all this information that isn't being used. It's really a little disappointing. So he devises the semantic web about 10 years ago. And then in 2007, he had an idea that tweaks the semantic web. Basically, I'm going to overstate this, but it drops the importance of ontologies from up here. The task of the semantic web is to build ontologies to, we need ontologies, but that's really not, they're getting in the way. So I'm not pretending to speak for Tim Berners-Lee. This is how it seems to me. So he had this idea for linked open data that would lower the barrier to getting semantics into and out of the web. And the idea behind linked data, just to sort of set the ground here, very simply, is that the linked data format consists of expressing data in triplets, a subject, an object, and a predicate that connects them. Two things in a relationship. That's the fundament of it. But the thing that's perhaps most revolutionary about it is not simply the simplicity of this format, but that each of these elements is itself, at best, a link. The data itself becomes linked. So Beethoven, what Beethoven do you mean? There are a number of them. Well, okay, if I'm going to express this triple, Beethoven should be a link pointing at some source, perhaps Encyclopedia of Music, doesn't matter, but some other source. And what do I mean by composed? Well, that's an activity, and that sort of activity, there are a number of ontologies and vocabularies that define it. Let's point at one standard one, the Dublin Core. The Emperor Concerto. Well, which emperor? I'm not sure which one that means. Okay, I'll point it at, say, Wikipedia or some other source. So in every case, each of these elements points outside of itself to some source so you can understand it. And so computers can understand it and can resolve ambiguities. And so you could have basically the same piece of data pointing at the same sources or at different sources. So which LV Beethoven, the way I've expressed this data, as I say LV Beethoven, well, we know it's the same one because it's pointing at the same entry in the Encyclopedia of Music. What does right mean? Concerto number 5, which one is that? Well, maybe I'm going to point my data at the German version of Wikipedia, but we can establish algorithmically a relationship between the German and the English entries for the Emperor Concerto, and so we can know, or the computer can know, that it's the same thing. So the point is, this is the world's shortest explanation of linked data. I'm sure many of you didn't need it at all, and some of you probably didn't want it, but there it is. The point is that data gets expressed this way in a very simple, regular form, but the data internally consists of links. This is no longer data that's inside of a spreadsheet, sort of trapped in its little corner, in its little box. This is data that at its heart and its nature consists of links. The third thing that this rise of the internet does for data, in this oversimplified view, which I will soon make slightly more complex, is that it opens it up. Everything's linked. That's the heart of the internet, of course, is that things are not locked. If they were, there would be no internet. So not locked in the data world, as the data moves out onto the internet, ideally not locked within a silo, within a particular organization, or even within the organization, not linked to a particular proprietary data format that nobody else can understand, because then it is not an asset. You might as well keep the safe locked if you're going to lock it up in a data format nobody else can understand, and not linked to a particular application. You developed the data because you thought it would be useful for a weather map or whatever, and somebody else sees that data and says, oh, this is really important environmental or industrial or information or for understanding the spread of disease. You don't know. It's not locked to an application, so we get multiple use out of it. This is happening. This type of data is being released in multiple fields. This is one of the most exciting things happening in our culture. And in our history, you've had 2,500 years of one track leading up to facts as a picture of the world. We are now having facts that are rare, that are assets, that are expensive. In genetics, in astronomy, libraries, governments, NGOs, the World Bank, the World Resources Institute, OpenGov.com or data.gov sites are opening up government data as well. This is becoming a norm in many fields. And this is releasing huge amounts of data in understandable, reusable form without guessing ahead of time of what people are going to do with it. It's open data. So those are the three things I think the internet does to data. Now there's lots of it, it's linked, and it's unlocked. And you get those three characteristics together, and what you have is a data commons. A huge, distributed mess and mass of data that can be reused. This enables us to model far more complexity than we ever could. Data from multiple regimes, multiple domains. It means that many eyes and many brains can look at it and discover the sorts of things that, that people do unexpectedly. They find a relationship no one else would have seen, and they do it across domains. And this data, because of its volume, because of the many eyes, because of the links, is more resilient than ever before, more robust than the fragile data collected very carefully by any one institution. This is really good for science. This is really good for business. So I want to talk about 3 shifts in our knowledge strategy that come about because of this new state of mind. So we have a traditional system of knowledge, which is based around the fact that the world is too big to know. The fact that that's a title of a book of mine coming out in January is purely coincidental. The world has always been, since Aristotle, since before, there's too much to know. We've known that for a long, long time. And so our strategy has been to break off brain-sized chunks of the world and to enable people to know those chunks really well. And those are experts, and they're tremendously helpful because we can go to them and we can ask them a question. We can say, whatever it is, what are the recent results? What's the atomic weight of carbon? And when the expert says it's 12.011, I'm not an expert, that might not be right, we stop asking because the expert knows. And this is a very efficient way of proceeding. But it means that our system of knowledge has basically been a system of stopping points. That's how we get efficiency in the knowledge system. We enable people to stop asking questions. I don't have to redo the experiments to discover the weight of carbon. I can just look it up in the book or ask the expert. And we have become the dominant species on the planet because of this strategy. This is a wonderful, wonderful strategy, but it is a reductive strategy. It's about reducing information, authenticating it, having a credentialing system that enables us to trust the person that we're asking because she or he has the degree or has written the book, is a genuine expert. It's a series of stopping points. Wonderful strategy, but it's not the way knowledge is. It's the way that knowledge works when what you have is paper as its medium. Because paper, we all love books. We all love paper. I work in a library. Paper is a hugely disconnected medium. The ideas in the books talk with one another, of course, because that's how culture works, especially when we allow it to. The paper in books are stopping points. You read through, why did the author, that seems wrong with the author. Oh, there's a footnote. I see why the author said it. So there is that pointer out, but for you to follow that pointer, you've got to get on a bus, get to a major city, find a library, and hope the book is in. No, none of us do that. Of course we don't. It's way too difficult. So books are, and knowledge has been shaped around this limitation of books, that books have to be complete enough that they hold the reader's attention and complete the topic enough so that the reader does not have to go out. It has given us a very compartmentalized, reduced sense of what knowledge is. It's only what makes it into the books, which are a relatively expensive medium. But now, of course, we are in the age of the internet, and you can think about hyperlinks as being a new type of punctuation. Old punctuation tells us where to stop. Hyperlinks tell us and enable us to continue. The fundamental difference. Hyperlinks connect the world in a way that our old strategy of knowledge assumed correctly was impossible. It was impossible until we had this new capability. And so it's my hypothesis that knowledge now resides at the level of the network, not in the brains of individuals, not in books, but in the network itself. If you want your organization to be smart, you have to build a smart network. Not all networks are smart. The intelligence of a network only has something to do with the intelligence of the people on it. Excuse me. And because knowledge resides at the level of the network, it's also taking on properties of the network. For example, Origin of Species, a masterpiece of science and of literature. In the first five chapters, Darwin lays out the argument. First 5 chapters, that's the theory of evolution by natural selection. The next 6 chapters, Darwin deals with imaginary objections. Now, some of the objections have come through his very intense social network, but he's thinking of everything that somebody might say in opposition to his book and anticipating it and putting it in the book, because that's what you have to do with paper, because paper is not a very responsive medium. It's the opposite of a responsive medium. So 6 chapters doing that, and wonderful. He's fantastic at doing it, of course. I mean, he's Darwin. It's no small thing. If he had been writing his book today, rather than waiting 30 years to publish it, presumably, let's say, he would have been blogging it as he thought it up. He would have been posting about it. on his site or other sites, and other people would have noticed, and they would have started talking, and they would have objected, and he would have responded in real time, and they would have applied it to new fields, and he would have said yes or no, or shaped it or ignored it, but somebody else would have picked up the thread. This network, much as Origin of Species is one of the most valuable works in human history, and it is, that work is more valuable being placed in a network. The network adds value to it. It also subtracts some value as people say stupid things, but those stupid things then get countered. It's not as if they weren't saying stupid things when the book was just a book. At least they're doing it in public now. The network has more value than any of its nodes. That's what I mean by saying that knowledge resides at the network. But insofar as knowledge is taking on the properties of the network, one of the chief properties of the network is that it's a network of differences, of disagreements. At best, linked disagreements. Every link that goes into the web is an expression of a human interest in something that is different from, in some way, is different from the person who is linking. So if you're blogging and you put in a link to something, you'll say why you want that person to go away from your site. Here's a link to a great comment, a great post, a beautiful idea, a stupid idea. Here's a link to something really funny. It's different from what I did, but I think you'll really enjoy it. Please go away. Just flick your finger like that, and please go away from my site. This little act of selflessness. Every link expresses some difference. And so you go on the web, and one of the things that almost inevitably you learn, even in a rights-restricted regime, one of the things that you learn is this fundamental truth that the net is exposing. So we look at it, and many of us react to the net this way, that it's a bunch of lies, and I can't believe how much people disagree, and so forth. But that's because the net is exposing this one long-hidden truth, which is we don't agree. We don't agree about anything. Never. Nothing. There is nothing that everybody agrees about. We just don't. That's not to say there's no right and wrong and whatever you believe is, no, not at all. Some things are, the world is one way and not all those other ways. But we just don't agree about it. And now we know the extent of the disagreement, which was hidden from us before by the nature of the media that we had. So we're in a world where we can see the fundamental disagreements that we have with one another. And we have two approaches. One is that we all get together and agree. That's not going to happen. My evidence for this is, I think, quite strong. It's all of human history. We are never going to agree about everything. So that's one approach. Let's leave that to the side. That's sort of a end of times approach when we're all lifted up. And the other possible approach is we say, oh, we're going to let's disagree fruitfully, usefully. And how can we do that? Well, in the 19th century, we spent a lot of time in the West arguing about whether this was a mammal, some type of weird lizard snake thing, whether it even could exist. People denied the evidence of the dead platypus that was brought from Australia with eggs in it on the grounds that it could not be because it violated the categories, the classification. So we lost a lot of time arguing about that. We no longer lose a lot of time arguing about that. Instead, what we have in the sciences and in many other places, although not always called this, what we have are name spaces. A space, a domain in which every name is unique, and the rules for constructing names are well established. The domain name system is one such, but so are telephone numbers and license plate numbers. Within the domain, every identifier is unique, and the rules are quite precise. So in a namespace approach, what we do is this. We have a bunch of scientists who disagree about what this thing is, how it should be taxonomized, how it should be called, and they say, okay, you know what, we disagree. Rather than arguing about this, let's each do our research, we'll each use our own name for it, and we will point. We will link to some common base that allows us to say that at least we're talking about that same thing. We disagree about what it is, but we're talking about the same thing. Namespaces allow for fruitful disagreement. They have enabled in genetics, for example, where there's tremendous disagreement about how to find and label genes, to advance very rapidly. Namespaces are a brilliant way of advancing while in disagreement, of fruitful disagreement. And we need this because disagreement is never going to go away, and is also the source of all innovation and advance. So the third thing I'd like to point at, and third and last, and I have one more thing to say, Eureka is an example of this. Eureka is a piece of software developed at Cornell, which will look through large, complex sets of data and discover relationships that humans might never, ever, ever have seen. The thing that's so it's a wonderful tool, apparently. The thing that's really interesting about it is it will derive formula that are correct, they're true and accurate, but humans cannot understand. We don't know why the formula works or exactly what it means. This is astounding. Similar sort of example. Systems biology, I am not a biologist of any sort, so forgive me, but systems biology, as I understand it, in the past 10 years or so, a new science, utterly dependent upon computers. You take systems biology, one of the main topics of study is how cells work within a system, individual cells. The most basic, simplest sort of atom, which are so complex that they need multiple computers hooked up together to be understood. So systems biology thinks of cells as information systems with signals coming in. A chemical touching its wall is a signal that has an effect on the other side. But the effects may be cascades of effects. So we can now identify the effects of individual chemicals, but the pathways, the multiple pathways through, and the number of chemicals and their interactions is so vast that human beings simply cannot understand them. The only way we can understand them is by putting the data into a computer, and the computer models them quite accurately. The computer understands them. So what I'm suggesting with both Eureka and with systems biology as just two examples is that we are in an age, in the age of big data, the data sense of mind, we are beginning to know things without being able to understand them. It's knowledge without understanding. It's not something we're very familiar with, but it's one of the results of the vast amounts and the complexity of data. So as one final example to think about, I want to compare the old, which is, say, the current view of how we model data, and the data commons view that I've been describing. And I guess I've been favoring also. I'm partisan in this. I think that the commons approach is so promising that I am urging it on us. So let's say you look out at the world and you see it's so scary and sad. You see all of these horrible things happening, more, not less, more, it's getting worse. And so you think quite reasonably, you know what, we have computers. We have computers that can handle lots of data. Maybe we can use them to try to figure out how to prevent or ameliorate these disasters. But you know that to do so will require modeling, because these are interactions between multiple fields. What happens in politics interacts with sociology, and ecology interacts with economics and biology and epidemiology, and you could fill up this entire wall with fields that would need to be understood in order to understand how things are happening on this planet. I left out meteorology, for example. That's sort of a big one, too. So what you think is, okay, so we're going to take our computers, we're going to model each of these, and then we're going to intersect the models. Because we have to. Because the world is unified. It's one world. And so we need to understand the effects among all of these. And this is just way too simple a drawing, of course. This is hugely simplified. I can see Jonathan's design head melting as he sees the crudity of this drawing. But it's the best I can do, okay? So, you're so judgmental, Jonathan. So judgmental. We've been bonding. So, we think all we have to do is model each of these and all the intersections, but the intersections, each of these is hard enough. When you intersect models, the error rate, the risk of error goes up very dramatically. You get, plus the little changes in initial conditions in complex systems, there's a butterfly effect, right? Can have enormous consequences throughout it. So the possibility of modeling one of these is hard enough, but to intersect all of them that you need to understand the problems that we face, and so, it seems implausible. There is another approach. There's value in everything we do, but suppose you were to build a data commons, which is to say that you were to contribute your data and take it as a civic responsibility. We build together as a planet a data commons that has more and more and more and more data from all sorts of fields. Some of them seem irrelevant. The data about what bats are eating in upstate New York may be completely irrelevant to everything. But it may turn out that if you notice that their stomachs are now filled up with mosquitoes, that indicates a change in the ecology that may mean that in 5 years you should be building solar plants because that's how it works. You are unlikely to get that out of the models. You are only going to get that, if at all, out of a data commons that has all of that data that includes many, many different sorts of models. Because there is no agreement about what the best model is. So many different models. It's open to many eyes. Somebody who says, wow, I just noticed the bellies of bats are filled up with mosquitoes. That seems weird, and follows that path. And many, many, many disagreements. The aim of this is not to come up with one idea. One of the reasons to do this is that this is the only way that we know of, I think, and tell me if I'm wrong, that we can scale data and knowledge to the size that it needs to scale. It's the only way we can do it. We can't get all of this we can't figure out what one model of the world is and get everything into it. We can only do it, and I have to emphasize, a key part of this is accepting disagreements. The attempt to drive out disagreements will destroy most of the benefits of a data commons. We can ask ourselves whether this approach, the data commons approach, is in fact, it's flawed. I mean, it's inconsistent, it's sort of ragged, it's never done. And so it seems flawed compared to the picture of the world that we had been hoping to get, of facts nailed down one by one, the world put together. I think it's highly arguable that this inconsistent data cloud that is constantly under disagreement is a better representation, a more true representation of the world than this one is. That the world, insofar as we can know it, is inconsistent, is always going to be subject to argument and disagreement. That is not a transitory state, that we disagree until we can come to final agreement. Perhaps we should accept that disagreement is the final state of knowledge. I'm talking as if I know. I'm not a scientist. I'm not a data person. I am certainly not a data visualizer. I think I've proven that today. So I acknowledge I could be entirely off base. But what I want to suggest is that in the new world, in the new data sense of mind, in the new world of data that the internet is enabling, we get data that is very different from what it had been. Rather than filtering into a few rows and columns, we have lots of it. It's rather than keeping it apart from other data, its essence now is to be linked. And rather than seeing it as an asset that has value insofar as we keep it locked in the corporate safe, unlocking it within your organization and even outside of your organization can bring tremendous benefit, not only to you, but also culturally. With this happening, I believe that we are already experiencing the beginning of a Precambrian explosion of ideas, data, knowledge, information, science, business, and culture. Thank you.
Thank you very much, David. Maybe I can hit you with one big question. This is Germany, and Germans always like to ask philosophical questions. Did you know that?
Yes, I did.
When you came to prepare yourself for this event?
I did have some awareness of that.
Yes.
And much admire it, one might add.
Okay.
Since Americans tend to ask questions about celebrities, so it's, you know.
In my view, when you look at the history of culture and science, people like to always be guided by a few big key people, key works, like the Bible, like Shakespeare, like Newton. They need orientation. Now, in this new setup, big data, is there a way that that can happen?
Oh,
And
sure.
isn't it necessary that it happens? Because we don't want to be just confronted with all the knowledge or all the data?
It's a profound question, which is to say I don't really have any idea, but I'll still try to answer.
Good.
So on the one hand, I want to say, yes, exactly. It's a wonderful point, and I don't know who the Newton will be. It could be Tim Berners-Lee of this new, and in some sense, it may be that the Newton is somewhat artificially decided, that it's not the person who invents the theory, but say Tim Berners-Lee for giving us the infrastructure in which the theory can be made real. I don't know. On the other hand, there is a possibility that that the old history of locating an idea in a single person and that person's work is really a book culture thing. That we do that because that person writes the book, that's the book that gets reprinted, and it's necessarily a filtered system and economy. It's not, leadership as you know, Leadership 2.0 was one of the topics on the board. Leadership is changing in the internet, age of the internet, and I believe it too is becoming a property of networks. If you look at the leadership of the large collaborative projects on the internet, Wikipedia, of course, always the best example, but Linux and others, the type of leadership is very, very different. It is not a single person. It is, in fact, a distributed leadership and network. So it may be that the nature of the internet as a medium will break our history of great men. It's generally been men, not a coincidence, given the social forces, great men and their books. Maybe, I don't know.
Let me open the discussion to our participants. Please give me a signal if you have a contribution, question, remark. Bitte.
You had this great example of what would have happened if Darwin had been blogging and he'd been on the social networks and interacting there. Obviously his work was fantastic. Do you have any kind of good examples from today's world where these things are happening in a more modern way?
Well, it's happening all the time. This is more so in some sciences than in others, but just stick with science for the moment. It's happening all the time. So one example was the P or not P problem in math. I am so not a math person, so if I get this wrong, I'm not going to describe the problem at all, but because I don't understand it. It's a mathematical problem that has been proposed, and there's a prize out for the first person to crack it. And there have been a number of attempts that people thought might work. The most recent one, the person who formulated the problem, name I don't remember, of course, passed around this one particular solution from somebody, said, I think so-and-so has really gotten it, and it started going through the networks. What happened was that this proof, which circulated very, very fast, faster than it could have through mathematical journals, and to people who would not have seen it because they do not subscribe to mathematical journals, and they don't happen to be at a university that's able to pay the $10,000 to $20,000 subscription for math journals. Open access is culture changing a requirement. That's just a personal opinion. Amateurs were able to see this proof and were able to challenge it successfully. The rapidity with which the knowledge was applied, the right experts, regardless of their credentials, were able to apply themselves to the problem, and that the discussion about the problem, the rapidity with all of this spread, the width to which it's spread across the network, is very much one simple example of knowledge existing at the level of the network, because the network of people were smarter than any of the individuals, and becoming a property of the network.
We have one more question right here.
David, do you think there will be a place for the copyright thing in this new model?
Sure, plenty of room for copyright. If copyright, you can tell this is something I care about, so I'll be very brief. If copyright tracked the actual earnings of authors in every different field, book authors generally, we stop making any money off of our books directly after about 5 years. If you're Stephen King or J.K. Rowling, then sure, much longer. but I don't really want all culture twisted around the needs of J.K. Rowling and Stephen King. They're great, but they can make their billion in their first 5 years. Make it 10 years. So if copyright tracked the actual earnings curve of creators in different fields, then we would have, in my view, a rational copyright system that said things are copyrighted only if you take out a special warrant for them, rather than everything being copyrighted instantly. My little notes that I wrote are copyrighted. That's ridiculous. I should at least have to go on the web and press a button and say, I'd like to copyright this. Thank you very much. And then have it last 5 years, 10 years, 15 years, 20 years, different fields, I don't know. 70 years after I'm dead, we're not talking about incentives for creators at that point. We're talking about incentives for greedy heirs. It has nothing to do with creativity or protecting culture. It's just about greed. So greatly shorten the term of copyright, make it something you have to actively apply for in some simple method, protect copyright vigorously at that level, absolutely. Yeah, sure, plenty of room for copyright, so long as it's serving culture's need and not the needs of greedy publishers. This is a personal opinion. Feel free to, attack me at any point. Thank you.